This video explains how to use my formula list to solve differentiation equations. Please download my formula list by scanning the QR codes here or by opening the URL www.singaporestudent.com/differentiation formula list 06. Now on the second part of this series of video, I want to explain on how to apply formula group B to solve differentiation equation. This is formula group B. If you notice, the formula are very similar to formula group A on the previous page on my formula list, and to be able to appreciate the similarities between these two group of formulas, I put these two group of formulas side by side. On your left, formula A1 to A6, and on the right is formula B1 to B6, and you notice that A1 and B1 are very similar, except for the letter U. What is U? U is a subfunction of y. It's not a variable, it's a function. It must contain x. It must contain x. If you look at note number 2, U is a function of x. U must contain variable x, where A and N, according to note number 1, must not contain variable x and y. If you compare that to formula group A, you notice I mark all the x variable with blue color on your left, and I mark the U, subfunction U, on the right with orange color. All are very similar, very similar. If you replace x on formula group A with U, then it will turn into formula group B. Another thing, usually I ask my students to mark the variable A and N with green color to indicate that all of these are constant. So A and N are constant, they must not contain any variable x. This is your comparing the equation of y for A and B. Then the next one, if you are comparing dy dx for formula group A and B, on your left is formula group A, and on the right is formula group B. They are also very similar. Here I mark all the subfunction U with orange color, and all the variable x on A with blue color. You notice the similarity, except for one part where you have the du dx du dx on formula group B, you notice there is no du dx on formula group Y. So besides replacing x with u to turn it into formula group B, you must also multiply the formula with du dx, and du dx is the differentiation of u. About the constant, you still must put the constant a and n, and as usual, a and n must not contain any variable. They must be constant. So two differences for the differentiation equation of formula group A and formula group B. The first one, formula group A contains the variable x, whereas formula group B use u, which is a function of x, and another one, formula group B must be multiplied with du dx. Later, I'm going to give several examples on how to apply this formula to solve your problem. You're going to understand easily because the formula are quite simple. Right now, the next part will be I'm going to give example to for the application of this formula. Hi. Now we try a very example. We call this example 1 of the application of formula group B for differentiation. Okay, I read the example here. Y equals to sine x squared. This question can be differentiated using two formula, B2. If you try to match the equation with the pattern there, it fits, right? In this case, A is equals to 1, U is x squared. Since you're using formula B, we must choose one more formula to solve for U, which means we must find du dx, right? Now, so the whole equation here, we apply formula B2 like this. Then for U, in this case x squared, we apply formula A1. In this case, A equals to 1, N equals to 2. So we apply two formula, B2 first, then after that we use formula A1. But when we do the working, you see here, I apply formula A1 first. So we differentiate the x squared first. We differentiate x squared. Dy dx is equals to a n x power n minus 1. A is 1, n is 2. So 1 times 2 is 2. N minus 1 is 1. So you get 2x power 1, which is 2 power x. Then we apply formula B2. d dx of sine x squared. Very simple. U is x squared, that means du dx is 2x. When we apply formula B2, we see the formula here, dy dx equals to du dx times a cosine u. In this case, a is 1 and u is x squared. Yeah? U is still x squared. A is equals to 1. So we get the final answer. d dx of sine x squared is equals to 2x cosine x squared, and this is dy dx. Now we do second example of differentiation using formula group B. In this case, we apply formula B3 and A1. Example 2, I read the question: y equals to 2 cosine x cubed. In this case, we apply formula B3 and A1. So remember, if you're using any formula in formula group B, you must choose at least one other formula to find du dx. In this case, A1. We check the question again here. 2 cosine something, right? 2 cosine something, that fits formula B3, the pattern on B3 here. In this case, A is 2, U is x cubed. U is x cubed, then we must find another formula to solve for du dx. Every time, remember, every time we use any formula on formula group B, we must find another formula to solve for du dx. U is x cubed. To find the differentiation of x cubed, we check on the formula list. Yeah, we have formula list on formula group A. It fits formula A1. X cubed, you compare it with ax power n. In this case, a is 1, n equals to 3. Now that we know we must use formula B3 and A1, we apply formula A1 first. A equals to 3, n equals to, A equals to 1, n equals to 3, which means an is 3, n minus 1 is 2. Right, so d dx of x cubed is 3x squared. And this 3x squared is used for the next part of the answer. D dx of 2 cosine x cubed, which simply means is equals to dy dx, because y equals to 2 cosine x cubed. Then we apply the formula. A is 2. In this case, A is 2, U equals to x cubed, du dx is equals to x squared. We simply put the value one by one here, right? Negative times du dx, which is 3x squared, times u times negative sine x cubed. If you simplify that, you get negative x squared sine x cubed. Now it's example 3. In this example, I'm going to use a combination of formula B4 and A1. B4 is y equals to A tangent U. which is suitable for this question. This question is y equals to 4 tangent x cubed. In this case, u is x cubed. If you're using formula A4, I think if you use formula A4, it will be wrong, because A4, the formula is y equals to a tangent x, and that is different. That is different from the x cubed. So you're not allowed to use formula A4. You must use formula B4. Then to differentiate x cubed, we use formula A1. I mark here. So you have two formula applicable here. Only for x cubed you use formula A1. Is suitable because it matches the question. In this case, if you're using formula A1, a equals to 1 and n equals to 3. Formula B4 also very suitable for this. Y equals to a tangent u, a equals to 4, and u is equals to x cubed. Now that we know that we must use these two formula, B4 and A1, which one must we use first? We use formula A1 from the inside. That means we don't do everything, we just use, we just differentiate the inside only for x cubed. Very simple. I think you get used to this already. The dx of x cubed is 3x squared, right? Because a equals to 1, n equals to 3, n minus 1 is 2, which means a n minus 1 is a times n is 3. Then you get 3x squared, no problem. The next one will be ddx of 4 tangent x cubed, which is dy dx. Then to do that, we apply formula before. Dy dx is equals to du dx. Du dx is 3x squared. Then we put 3x squared there times a. What is a? A is 4. A is 4, like this. We don't use tangent, we use secant square. Secant square u. In this case, u is x cubed. Some students get confused. Instead of secant square x cubed, they put secant square 3x squared. No. 3x squared is du dx. U is x cubed. The formula say is secant square u. If you simplify the dy dx, you get 12x squared secant square x cubed. That's example 3, which is very simple. Next, we do example 4. Also very simple. In this example, I'm going to use a combination of formula B5 and A1. And why I choose that? Very simple, because it matches the question. Because the question is 5e power x cubed, and it matches here. A is 5 and u is x cubed, and x cubed you can apply here, where a is equals to 1 and n equals to 3 if you apply formula for a1. Now that we know we must use formula B5 and A1. Which one you must use first? B5, of course. No, A1. We do from the inside. We must use formula A1. ddx of x cubed, very simple, is 3x squared. You already remember the formula. dy dx is equals to a n x power n minus 1. A is 1, n is 3, which means n minus 1 is 2. So the power decreased by 1, 3x squared. Next, we use formula B4. ddx of 5e power x cubed, and x cubed is u, which means du dx is 3x squared and we apply this into formula, because according to formula we have du dx here. This du dx is 3x squared. A equals to 5. U is x cubed. Then we apply here 3x squared times A, which is 5, and x cubed, e power u is e power x cubed. Very simple, and if you simplify them, you get 15x squared e power x cubed. So that's the answer for example 4. Very simple. Now example 5. In this example, I'm going to use two formulas, V6 and A1. As you see on the screen here, y equals to ln x cubed, and the suitable formula to solve this problem is formula V6, y equals to a ln u. In this case, a is 1, u is x cubed. If you look at the screen, if you replace a with 1 and u with x cubed, it fits. It's exactly the same as the question. We need to use formula A1. Formula B6 is not enough. We must use formula A1 also. The reason? Very simple. Because later you must differentiate x cubed. So whatever expression u is, you must find the differentiation of that, and the best formula to use is formula A1. If you replace y with x cubed in formula A1, then a must be equals to 1 and n equals to 3. Now we know that we must use formula B6 and A1. When we differentiate it, we use formula A1 and B6 dy dx. We use formula A1 first. We do the other way around. When you want to choose the formula, you check formula B6 first, then A1. When we want to apply it, we use formula A1 first, then B6. We apply formula A1. A is equals to 1, as we've seen before, n equals to 3. N minus 1 is 2. Hence, dy dx will be 1 times 3 x power 2, which is 3x squared. This 3x squared, we substitute that expression into du dx in formula B6. So du dx is 3x squared, a also equals to 1, and u is x cubed, which means after you substitute that, dy dx will be equals to 3x squared times 1 times 1 over x cubed. And if you do that, if you simplify, you get 3 over x. Very simple. That is example 5, ln x cubed. Now we continue example 6, y equals to 4 cosine square x. Now some of the students might get confused with this formula, 4 cosine square x. It simply means 4 times cosine x squared, the square applied to cosine x. And the formula that is suitable to differentiate this equation is B1. A is equals to 4 and equals to 2 because you square the cosine x, and u is cosine x. And that cosine x is y in formula A3. Y equals to a cosine x. If you compare it to cosine x, that means a is equals to 1. Very simple. That's how we recognize, how we choose the formula. We know we must use formula B1 then A3. When we find the differentiation, we do the opposite order. We apply formula A3 first. A equals to 1 here. dy dx is equals to negative a sine x, and a is equals to 1. So dy dx will be negative sine x. Then this dy dx is du dx in formula B1. So dy dx in formula A3 is actually du dx in formula B1. You put it there and we apply the value of a. I think a is 2, right? No, a is 4 and n is 2, which means n minus 1 is 1. And du dx is negative sine x. U itself, how about u itself? Du dx is negative sine x. A lot of students make mistakes. They think that du dx and u are the same. No, du dx are different. Du dx are different from u. In this case, du dx is negative sine x. U is cosine x in the original equation. Very simple. Du dx is negative sine x, u is cosine x, a is 4, n is 2, n minus 1 is 1. When we put all this expression into dy dx, so dy dx is equals to negative sine x times 4 times 2 times cosine x. You can put power 1, but we don't have to, because power 1 means you don't have to write. And if you do that, if you simplify this expression, you will get negative 8 sine x cosine x, and that is the answer for example 6. For example 6 negative 8 sine x cosine x. Next one, example 7. Y equals to tangent of ln x cubed. This example, to solve this question, we are going to use 3 formula, and I think you know which formula to, at this stage you know which formula to use. Definitely you're going to use formula before, right? A equals to tangent, y equals to a tangent u, because in the question there is tangent function. We are going to use also formula B6 because in the question there is ln, so y equals to a ln u. And the third one, we are going to use formula A1 because there is x cubed there, y equals to ax power n. So we know which formula to use already. But which one we apply first? Very simple. I make this diagram here. On the inside is formula A1 because x cubed is inside of ln. So formula A1 is inside formula B6. B6 is ln. And ln x cubed, formula B6 is inside formula B4. B4 is formula for tangent. Now we try to put in values and expression inside these formulas. When you apply formula B4 to the question, in this case a will be 1 because you're comparing y equals to tangent ln x cubed with y equals to a tangent u. A will be 1 because there's nothing there in front of the tangent. U will be ln x cubed. If you replace a with 1 and replace u with ln x cubed, you get the original question, right? The function there. Next one, this u, which is ln x cubed, we apply formula B6 there. In this case, a is equals to 1 because there is nothing in front of ln, so it's 1. U is x cubed. This u here become y on formula A1. Y equals to x cubed. In that case, a is equals to 1 again and n is 3. That's quite simple. When we differentiate them, we do the opposite direction. We start from the inside to outside, which means we start from formula A1, B6, then B4. We apply formula A1 first. A is equals to 1, n equals to 3, and n minus 1 is 2, which means dy dx is 3x squared. That dy dx of 3x squared is actually du dx for formula B6 is du dx, and for formula B6 a is equals to 1 u is not 3x squared but x cubed. Very simple. Now we just replace du dx with 3x squared, a with 1 and u with x cubed. We write that thing down, 3x squared times 1 times 1 over x cubed. If you simplify them, you get 3 over x. And that 3 over x is du dx for the next formula, which is formula B4. Formula B4. So du dx, you're going to replace it with 3 over x, and a is equals to 1 secant square u. What is u? U is not 3 over x but ln x cubed. Then we find the final answer. The final answer is dy dx equals to 3 over x. Then you replace a with 1 times secant square ln x cubed. If you simplify the expression, you're going to get 3 over x secant square of ln x cubed. That's the answer. We apply the formula from the inside to outside. The first one we apply to A1, after that B6, and after that B4. That's how we solve question in example 7. Next, I'm going to give a similar example, also quite complicated. Instead of using 2 formulas, we are going to use 3 formulas also, like example 7. Similar, I read the question, y equals to cosine e power tangent x, which means the equation contains cosine, which means you're going to apply formula B3. The formula also, the equation also contains e power something, which means you're going to use formula B5, and there is tangent x there, which means you're going to use formula A4. Which one we apply first? We just look at this diagram here. A4, which is tangent x, is inside e power something, which is formula B5, and both of them are inside formula B3, which is cosine. Then later when we differentiate, we are going to do the opposite direction, from inside to outside. We are going to apply formula A4. After that, we are going to use formula B5. Then after that, we use formula B3. Now we apply formula A4. But before that, we try to get the values of A and U for all of them. For formula, when we apply formula B3 here, cosine something, there's nothing in front of cosine. The coefficient of cosine is empty space, which means it's A. U is e power tangent x. If you replace A with 1 and U with tangent x, you're going to get the question. You're going to get the equation from the question. Then that U, which is e power tangent x, becomes y on formula B5. There's nothing in front of e, the coefficient of e is 1, so a is equals to 1, and u will be tangent x. U for formula B5 become y for formula A4. In this case, a is equals to 1. So very simple. A for formula B3 is 1. A for formula B5 also 1. A for formula A4 also 1. U for formula B3 is e power tangent x. U for formula B5 is tangent x. Then we apply to the differentiation equation. First we apply A4, then after that B5, then after that B3. Formula A4, A equals to 1, which means dy dx is equals to secant square x, because 1 times secant square x is secant square x. Sorry, I think I'm not supposed to call it dy dx. Is secant square x, because dy dx for formula A4 become du dx for formula B5, which means we already know the value of du dx in formula B5. Then a here will be 1, as we know before from the previous working, and u is tangent x, not secant square x, because secant square x is du dx, which means we can find dy dx easily because we already substitute all the values and expression. Dy dx will be secant square x times 1 e power tangent x. That's du dx. Du dx for B3 or dy dx for B5. Later we are going to substitute du dx with secant square x e power tangent x. U itself is e power tangent x, and a is equals to 1. We substitute all the expression and constant here. That means our final answer is like this: negative secant square x e power tangent x sine e power tangent x. That's the answer. I think by now you're already quite familiar with formula group B. You can easily apply the formula to solve your problem.